All right, today I am doing the final project for design of aerospace experiments, part one. This is that. So I'm going to start with workbench and then open a new fluid flow project right there. Let's call it video. And design modeler. Once design modeler is open, I'm going to just turn my view like that. Go to concept, curve, and then curve from coordinate file, and then select the coordinate file. I already have the coordinate file downloaded for the NACA 2415. It's going to be formatted in a certain way, and I've already gone ahead and done that from when I downloaded it. So if I press open, it imports it just like that. And I'll go and generate that so it's there. Then I'll go to lines from edges, and select that edge, apply, and then generate that. So we have lines created. It's that we need surfaces from edges. This edge, apply, and then we go and generate that. It turns into a surface. So that's how we're going to start there. Now what I'm going to do is go to the XY plane and create a new sketch. Go into sketching, arc by 3 points, create the arc for this. There. Then modify dimensions. It just to make sure this arc is lined up with the origin like that. And we'll do another one. So draw and no. Go to general and look at this. We're gonna want this at 4.5. And you'll notice this is actually just not the right size. So to fix that, we'll go back to model and we're going to order this curve here and we can just put meter to centimeter. Again. We want to be pretty small inside of our enclosure. Next, we're going to do rectangle by 3 points. We're going to make sure we're still working with one rectangle by 3 points. Like that. Dimension, general dimension. And then let's make sure that this is also. This will be kind of our wind tunnel. It's not actually just a wind tunnel, it's just a box. That looks good. Our last step is going to be just to erase this middle line right here. So that looks good. What we're going to do now is bring this sketch. Good. And now we just want to cut out this middle part so let's zoom into so you can see it. See it. think actually here's a good point to do some information. What I'll do is create body transformation, rotate. The body we want for this is the surface. Want flat line. Zero for now, but we do want to do parameter. The parameter we can easy to do the calculator at different angles of calculator. If I want to do this, the whole part. And we'll do that. We'll go back to create body transformation. First, generate the body transformation. Translate body as direction this axis, and then want to move back one. So that looks great. Again, convert the back mark. Which is what we want. All right, so the next thing to do is to take the cutout that we need boolean right perfect body is the big one. Body is this big one, fine. Tool body is going to be this the wing, and I selected by using this in the corner, whatever. Geometry setup, we're good to go. We're going to close this. And using the parameter mark off by default. I'm going to leave that how it is for now. Now we're going to go here to mesh. We're going to go start editing the mesh. So we'll edit, and we're going to let it open up for us here. I guess while it's opening, I'll explain what's going on with the parameters. This is the project that I used to that's what I used to complete the assignment. This is the one I'm using for the video. So when I did this, I had to create a parameter set. You see it here. And so we're going to be able to edit the same parameters. It's going to edit both of them, but I'll explain how the parameters work because you use that to get the information for various symbols which have more than one. Actually, side like this. Go to mesh, insert method, geometry. This one, like triangles. That looks good. Go back here to mesh, insert, go to sizing, and for type, we're gonna go divisions and number of divisions. The geometry I want this edge select that edge here. All of this edges. Edge. Divisions. I want 300 divisions of bias. Bias here. I'll put a bias factor of 150. This does create a lot of basically makes it so that there's more meshes along surfaces. Insert finally, down here, and we'll have looks good for me. So we'll go to mesh and we'll generate that. Uh, Fashion was relatively large meshes along the outside, but then we get closer and closer to the wing, we have smaller for the outward around this lower go ahead and update just to make sure everything is done. Cool, the mesh transition is also successful, so we can close this. Now we'll go to our setup. Double precision, we'll use all this. We'll see the process by which we're calculating everything. Okay, here for us. And let's go over the setup real quickly. Okay, there's actually did forget to do, and we'll have to go back to the measure. I'm going to close out of this. And what we forgot to do was label our mesh selections. We'll go back here and we'll mesh. We'll do that. Uh, Here is the right edge selection. We can select everything. So we go on edge. Click on the button. You can create a name selection for it. This is going to be our inlet. We'll have here. One is your outlet. And we have this up here and this down here. This thing will be our yes. And then finally, put on your the airflow and like this. Here. Now that that's done, we can update. Maybe this little message here. Transition successful. Uh, yeah, the next thing we do want to load the new mesh because the new mesh is what contains all my selections. So everything clicks in here and press start. Now, hopefully, if we did this right, everything in the setup will actually already be kind of ready to go based on the selection that we created. And this makes it easier for us to set our boundary conditions. Let it load in and we'll take a look. Zones, that's pretty good. All right, so let's take a look at our boundary conditions now. We have inlet. Look at our inlet here. Open up inlet. And so what I want to do here is set the magnitude to 15. Because that's what the problem says. And then for normal to boundary, we're going to want it all going in the x direction. So we'll go back into the direction. And just color the x direction. Like that there. Now we can go to okay, that looks fine. So what we're going to want to do next is make sure our model here is set to the whatever you want it to. We're using viscous burns, and we're going to use K epsilon, realizable, and the same. Now, that was based on the tutorial that I want. Then materials, we want fluid, we want air, and just note down the density. Obviously, the density is known, so we'll leave that the same. Everything here looks fine. Looks fine. Looks good. Looks good. So we'll go down here to initialization now. Standard initialization, computing from the inlet out that way. Everything here is the same. Initial values, everything looks good. Then we can initialize. That's good. We can go to run calculation now. And we'll set our number of iterations to 100. You can go more or less depending on the computing power of your processor, excuse me, and then we'll go ahead and calculate this and see what we get. Let's take a look at the graphics. We already get some velocity contours. So we'll get velocity contour of uh, interior body surface. Looks good. And we'll get the wall surface body as well. That's the airfoil. And we'll complete and save and display. We'll see what it looks like. We'll zoom into the middle. And we're going to get that is our velocity contour right there. Pretty good. And then if we want, we'll close that. Fine. And here's its body and body. Display, and that is our static pressure. Next, what you would do now to get the different angles is you could go back to the geometry design modeler and just change that parameter. But the faster way of doing that is what I'll show you now. You can save all that stuff so that it can run those calculations every time. Exactly the way that we set it up. So now the way you would get it to provide the information that you want as far as coefficient of lift and coefficient of drag. You're going to go to the post expression, and it's actually possible for us here to create a new expression. We'll call it CL, and then you can use the things up here to create a new CL. So one of the things that we would have had to have done, so what you do here is you would insert the formula for CL based on things like the force across the x and the force across the y, and you could use that. I put the calculation to find coefficient of lift. You could put the formula through output. But where's that output? So that's what I'll show you next. Is where does that output go? The way I got the output is I would use the parameters tab. And you're going to open up parameters set. And obviously some of this has already been done by me because I did the project earlier. But what you do is you create new design points on this tab on the left. You can see the angles I used here. You can see so these are the angles attack for P1, which is my first run. So for the second run, you're going to, for my newest one, you're going to be changing the angles here, right here, and the outputs are all going to be here. So you're going to basically put the formula for lift and drag come from the results tab that we just looked at, and then you put the calculation for coefficient of lift, coefficient of drag, and it will make a table for you on this side. And how this saves time is that you got all the angles that you wanted to iterate through here, and you can press this button where it says update all design points. I'm not going to press it because it's going to take the time to simulate every single one of these different setups that I created. So I don't want to do that right now, but if you press this, then it would do that. So you can actually put as many angles as you want, and it'll go in order one at a time and then give you the information that you ask for. I didn't find a way for it to give me the contours. So the way I've been doing that is you ask it to press retain here so that it retains all of the data after it runs it. And then I open up each solution file and download the contours manually. There probably is a way to get the contours all at once. I just don't know what that would be. So what I did after this is I just took the angle of attack from here, the coefficient of lift, the coefficient of drag, put it into Excel, and then used Excel to create the plot. But that's everything for part 1 of the final project. Thank you.